There's a number of terms that get used in machine learning or AI. AI, or artificial intelligence, is really the original term to describe a computer system that exhibits some sort of intelligence. Machine learning is the notion of a machine actually physically learning to do something as opposed to being programmed. Machine learning looks at real-world examples of occurrences, of causes and effects, and it learns to predict those. It learns to understand them. So if you're using your iPhone and you're typing a message to somebody and it's auto-completing, that system's watching millions and millions of people's sentences and is constantly learning to predict what's going to be said next. That's a machine learning system. One example that everybody knows about today is self-driving cars. For these cars to actually be able to reason about hundreds of other human beings on the road doing complicated random things that might sometimes not even make sense is really tricky. But it's only now with the sudden power and availability of AI that we can begin to deal with that kind of complex data. So suddenly, you're dramatically reducing deaths on roads. You suddenly, extended the availability of transport to more people. And that's truly transformative. So the thing that makes me the most excited about applying AI in our technology here at Autodesk is the fact that we are working with 3D data. One of the first machine learning projects we took on here at Autodesk, we built a piece of technology called the design graph. Now, what the design graph does is it takes large amounts of 3D content from dozens, hundreds, thousands of users and learns from that 3D content. First, it learns to categorize things and classify things. So it learns the difference between a nut and a bolt and a screw and a bracket. Once it's learned to categorize the world of components, it can then look at assembly, whether the assembly is a piece of machinery or any larger model. The design graph can actually classify the larger model in terms of the nature of components inside it, because it's learned to understand those components. So for example, if it sees something that's got wheels, it's got an engine, it's got spokes, it's got a gearing system, handlebars, it can infer that it's a motorcycle. One of the key areas where I think this is really transformative is in robotics. Our project to test this out is a project that we call the Lego bot. And the idea is that it can be faced with a random jumble of Lego bricks on a table. And the robot can perceive those Lego bricks, it can sort through them, it can find bricks, it can learn how to pick them up and hold them. And then the robot can actually start to construct an entire Lego model without ever having either seen that Lego model before or even the components. We believe if we can solve that problem, then we will revolutionize industrial robotics. You just put robots into your factory and the robots will kind of automatically begin to do what needs to be done. So there's no doubt about it. I mean, artificial intelligence is going to fundamentally change the way we do work. An AI system can actually help design by showing you options and possibilities that you might not think of. And then I think whether you're designing cars or you're designing electrical products or you're designing movies or you're designing buildings, I think all design is going to improve.